Definition of a hyperbola. For two given points, so that's this foci and this one, this focus point and that focus point, called the foci, a hyperbola is a set of points such that the absolute value of the difference between the distance to each focus is a constant, and we're going to name that 2a for a very good reason. So in other words, the point to 1 subtracted with the distance to the point to the other one has to be a constant for all the points. Now, if you show the subtraction the way I'm going to in a moment, you'll start to see that this 2a is very important and that the a has a very special meaning on this picture. Alright, so we swing this arc here, this arc right there, and we show the subtraction of this distance minus the d1 distance, and that comes out to be illustrated as this distance right here. Okay, and I want you to realize that every time we do this, that distance, which is constant, is going to be equal to this distance. So this distance here is going to be the 2a from this point to that point, and those are going to be called vertices of this hyperbola. So I'm going to do a few more pictures here, and every time we swing this arc and subtract one distance away from the other one, the resulting remaining distance is always going to be the same length as this 2a across here. That's going to mean that from the origin to the vertice or the vertex point is a. The distance here will just be 1a, and the distance on the other side will be 1a. Now here's another point on the hyperbola, and d1 is here and d2 is here, and I want you to notice as we swing the arc that the remaining cutoff distance will still be that 2a across here. Now notice that as we swing the arc, the cutoff remaining distance from the subtraction is this long, from here to here, and again that's exactly how long it is from here to here. So again, this will be the defining subtraction, and that's going to be equal to this again. Now I move the, okay, so right here, so the distance to the foci is here, and the distance to the other foci is here, and if you subtract them, that's like taking this away from this. So 1, 2, so 1, 2. So now you're talking about a distance from here to here remaining. And that is exactly the same. Let's just count it. 1, 2, 3, 4, 5, 6. It's a distance of 6. And again, this distance is 1, 2, 3, 4, 5, 6. So I think this makes you believe that that defining distance of 2a shows up as this distance between the vertices from here to here. That's 2a. That makes this be a and this be a in there. So now I show another point here, xy over here, and show that still the subtraction with the absolute value still gives you the 2a. So I swing this arc and the cutoff distance is here, and I think you can see that that is the same still as this So this is the 2a, so that makes this the 2a, that makes this a, and that a. Now I also wanted to show you that the hyperbola can open in the x direction, and again here's a point on the hyperbola, and if you illustrate the subtraction of the two distances, say this is d2 minus d1, then you will get this as the resulting remaining part from the subtraction as these two knock off, and that will be the same as from here to here, and that will be the 2a, and that will be the 2a. Now we have another video coming up that shows more attributes of the hyperbola.